Hey, how's it going, everybody? Mr. Tannen here with another video coming right at you. I had some questions on my video calls on Friday about how are you able to find the amplitude, period, and midline of a sine or cosine function when you're just given the function. So we went over those graphs in my previous video. If I'm just to do a quick sketch, right, our sine is like this, where it starts at 0, that would be y equals sine of x, and our cosine starts at 1 and then has the same type of curve, that would be y equals cosine of x. So if we are going to think about this here, if we were to shift this graph left or right, either of these graphs, up or down, left or right, it's going to affect neither the amplitude nor the period, right? Because the amount of time it takes for the graph to repeat, right, make that whole repeat, which in the normal case is 2 pi, that's not going to be affected by a shift, by a translation. It could be moved vertically, horizontally, but it's still going to have the same period and it's going to have the same amplitude because it's not going to be going any higher or lower from its midline. However, its midline would be changed. But when we're talking about the stretches or shrinks of a function, that is what's going to have a big impact on the amplitude and period of a sinusoid, which are what we call these style of graphs. So, for instance, when I do a stretch or shrink, we could think about the format of it as we have, let me do a different color here actually. Well, here, let's do it this way. So we've got our sine function, our cos function. But when we end up putting something here that gets multiplied, right, by the sine or cos, that would have a vertical, cause a vertical stretch or shrink. And if you think about it here, well, the normal amplitude of my sine or cosine function is just 1, right? For my sine, for instance, when it's pi over 2 here, right? The output is 1. So whatever we're multiplying the function by, it's basically that maximum or minimum if we're going below there, which I know I didn't do a good job drawing it perfectly. That's just being multiplied by a factor of a. So whatever it is, whether this this vertical stretch or shrink factor is positive or negative, the new amplitude is just going to be basically the absolute value of that a. Because even if it's negative, if you think about it here, it would flip it, but the amplitude would still be, let's say if it was 2, it would just be double going down, but it would still then come up here double above, right? It would be something like this if it had a factor of -2. So basically, basically look at the coefficient and take the absolute value of it. That gives you the new amplitude. The period is a horizontal measurement, right? It's how long does it take for the graph to repeat. And we know the normal function takes 2 pi for both sine and cosine, the normal period, I should say, for the parent function is 2 pi. But if I drop in a little, we know that when we multiply by the input, often it's nice for us to have parentheses here, that's what causes a horizontal stretch or shrink. But it has an inverse relationship. So remember, if we were to multiply it by 2, like sine of 2x, it's actually a horizontal shrink by a factor of 1/2. Or you could say it's divided by 1/2. So it would actually be repeating twice as fast. So one way we could say the period, just by looking at the function, well, it's just going to be the original period, which would be 2 pi, divided by the absolute value of b. Let's think about this for a second before we try it on a few problems. So for instance here, if we've multiplied the input by 2, well, it's a shrink by 1/2, so we're going to do 2 pi divided by absolute value of 2, which is just 2 pi over 2, which is just pi. So it's going to take half as long to repeat, which makes sense because we're shrinking it by a factor of 2. Okay, let's try to apply it with some quick examples here. So I pulled this example. It's number 19 on page 491 of the textbook, which was not assigned to you. So one other thing I want to make sure you know is this 4x, it's often not in parentheses, but it's still the cosine of the 4x. It's not the cosine of 4 times x. If it's written as it is here, and as you see in the book often or on Khan Academy, parentheses aren't always needed. So right away, I see this 1/3 in front. Well, that's my a value, so I know right away that the amplitude, it's not going to 1. Instead, the highest it's going to get is just going to be 1/3. So the amplitude is 1/3. And let's think about what the period would be. Well, the period is just going to be 2 pi. Well, remember, it's got the reciprocal factor, 2 pi over 4. Well, that simplifies to just pi over 2, which is 1/4 of the original period, which makes sense because we're shrinking it by a factor of 4. So the period is pi over 2. The one thing we still haven't talked about here is the midline. Well, the midline is not going to be affected by shrinks or stretches, right? It's only be affected by shifts. So if we want to add the midline to this here, let's say that we have in a different color, we have a plus a c here, right? Well, that plus c is just going to end up being the midline. The midline is just going to be the equation. It's going to be the horizontal line, which is y equals that new value. So it's normally at y equals 0, but if it's shifted up or down by that c value, the new midline is just going to be y equals c. So for the example I chose, there's nothing being added. So the midline is still just, in this one, the midline is still y equals 0, which is just the x-axis. Only if we had something being added at the end would the midline be affected. So let's look at an example where the midline has been moved. So this is an example, it's number 33 from page 492 of the textbook, actually not 493. So let's take a look at this one because we got some different stuff happening. Well, we can see there's a horizontal, that's going to be a stretch actually because it's the reciprocal, right, by 2. This is going to be a horizontal shift. The funky thing is a shift isn't going to affect anything. The period will still be the same because actually if you shift the sine function by 2 pi, it's just going to be exactly the same because it's a repeating function. Oh, interesting. So the amplitude for this one, actually it hasn't been affected at all. So the amplitude is still going to be 1. The period, well, it's, as we said, it's just 2 pi divided by that value. So 2 pi divided by 1/2, well, it's the same as multiplying by the reciprocal. So that period is going to be 4 pi, which makes sense because it's a stretch by 2 horizontally, so it's twice as long. Now the midline here, well, it's just been shifted up 3, so the midline is just going to be at the line y equals 3. All you really have to do is just look at that vertical shift to find the midline. So these aren't too bad. Hopefully this helped if you're having trouble identifying how to find the amplitude, period, and midline just by looking at the function. Much love to everybody. Hope you're doing well. Don't hesitate to reach out. You know where to find me. Bye-bye.